So virtualization is important to Microsoft because it's important to our customers. We've seen a trend in virtualization, or more people leveraging virtualization starting about 10 years ago, where first we saw it in dev and test environments where people can configure virtual machines that represent different states of the operating system or applications and then go between those states very quickly to test changes to the environment, to the application. And then we started seeing server consolidation, where people take physical servers that are underutilized and put workloads that are nicely isolated and contained inside of virtual machines on a physical server and share those resources across the VMs to more fully utilize the server capacity. And as, of course, IT costs are under more and more scrutiny, especially with the state of the economy, power is another issue that drives for server consolidation, and heat and space too. Data center sprawl is one thing that people wrestle with, where they've got lots of physical servers that they run out of capacity. It's just physical space capacity and cooling capacity. So all of those factors are pushing more and more people into virtualization. So it's important to Microsoft, and as a technology, what we want to do is we believe that that's part of the infrastructure platform that underlies Windows. And so it makes sense to build in knowledge of virtualization, build in virtualization technology into Windows itself, because by having that technology in Windows, Windows can run very efficiently on a virtualized substrate, on those virtualized servers. And so our goal is ultimately to provide the best of breed virtualization technology at the best price too for our customers, the same way that we provide OSs that way. If you look at fundamentally what virtualization technology is, it's taking an operating system and running it inside of a box where it believes that it's actually running on the physical hardware. And what we do on top of that is put in what are called enlightenments into that virtual machine. And what enlightenments are, or integration components, they're called in Hyper-V, are knowledge in the virtual machine, in the OS, that it knows it's running on a virtual machine. And that allows it to do things more efficiently by cooperating with the hypervisor and the virtual machine manager. It can optimize I/O, for example, in a way that makes it much more efficient than if the VM is just treated as a black box and the hypervisor doesn't really know what's going on in it. And all of us, Citrix and VMware and us, have put enlightenments into our OSs. We believe we're doing differently is that because we actually understand Windows, probably obviously better than anybody else, that we can enlighten it better than anybody else and make it run most efficiently, taking advantage of whatever hypervisor is underneath. But fundamentally, that kind of virtualization technology is being commoditized over time. And as we put improvements in, or VMware puts improvements in, everybody's going to be matching each other. And in the end, they're going to be roughly comparable in terms of the performance, in terms of the capabilities of the virtualization technology. So one thing that we're doing that we feel we're in a unique position for is driving virtualization really to the management level. Because if you've got virtual machines across your enterprise, across the data center, the problem you're going to be faced with is, how do I manage those virtual machine images? How do I service them? How do I make sure that they're compliant with corporate policies? And that's where System Center comes in. System Center Virtual Machine Manager to manage virtual machines across physical nodes, and we can manage Server 2005, Virtual Server 2005, or Hyper-V, or VMware ESX. Even if people have that in their environment, we can manage those virtual machines as well from System Center. Okay, so there's two types of virtual desktop infrastructure, or virtualized desktops. One is virtual machines. They're running in a server, and users connect to those virtual machines from their own desktops. And that might be a thin client even, that they're connecting to those virtual machines that are powered up on demand on the server farm, and then their displays are remoted out to the clients, much like remote desktop for terminal services, except you're actually giving the user a full virtual machine. When that user is done working with that virtual machine, the virtual machine is shut down, it's not consuming any resource, and the user then can move to a different desktop and fire it up and connect to it and resume what they were doing in that virtual machine. So that's one way to use virtual desktop infrastructure. Another way is to actually push the virtual machines out to the clients, and we're seeing this in Europe where users are buying their own machines but then doing corporate work on them, or the corporation's buying the machines for the users, like a laptop that they get to take home and then use as a personal computer. And the companies, for security and compliance concerns, don't want to run corporate software on top of those unmanaged desktops. So what they do is give the users a virtual machine that's running on their own host OS. When they need to do work, they fire it up. That machine is connected back into the IT infrastructure back in the office. They do their work, and when they're done, they shut it down, and IT is in full control of that patch levels and servicing and security in that virtual machine. So with that kind of virtualization, where desktops are either pushed down as VMs to the client, or they're connected back to VMs that are running on a server farm, our ambition matches what our customers want to do. So if we see customers want those kinds of solutions, which we do, we're building in support for that. So we've got Terminal Server Gateway today, which is a gateway into a server farm of terminal servers that proxies user connections into their desktops and their terminal server desktops. We're also looking at building in that same kind of gateway capability for virtual machines. So a user would connect to a gateway. That gateway then would work with the back-end virtual machine management technology to fire up the VMs on demand and connect to them and place them on the appropriate physical server on the back end. And as far as these virtual machines that might be pushed out to a client machine, what we want to do is end users don't necessarily understand the concept of a virtual machine running on their host OS. And so we bought Kadaro, which is a company that works on integrating the software that's running inside the virtual machine with a user's desktop that's hosting that virtual machine. So they'll see in their start menu an application shortcut that's really referencing software that's installed in that virtual machine. So they go click it. If the virtual machine's not launched, it fires up. And then the software itself is projected out of the virtual machine onto the user's desktop. They don't realize that there's actually a separate OS. It looks like an application that's just running on their host OS. And so we've got that technology, and that's part of Microsoft Desktop Optimization Pack to create that nice integration for end users so that they can understand and use that kind of virtual machine solution.